In humans, the quickest cerebral growth period is during infancy and early childhood. The years of 7 to 11 showed a decline in cerebral and body growth, which gives time for the brain to grow. The evidence of human neoteny tends to be outlined in neurological structures and processes as well as human genetics. More generally, neoteny contributes to the prefrontal cortex's functional maturity as well as development of strong cognitive and emotional talents. There are many neurological associations with neoteny and humans that can be used as evidence to explain how neoteny is a relevant evolutionary concept. An adult human brain uses 20 to 25% of their metabolic energy when at rest compared to similar species such as apes who use 11 to 13%. This suggested a rise in cerebral metabolism in humans that can be explained by the increase in neuronal and synaptic activity due to the occurrence of synaptic plasticity. The brain of a child also shows the increased levels of synaptic plasticity and elevated neuronal metabolism. Evidently, certain cortical neurons have been retained even into adulthood to better the species by allowing us to use more metabolic energy. This is a key example of how a neotenic characteristic has evolutionary benefits. There are benefits of increased synaptic plasticity. Humans depend on the progression and transmission of culture via language, meaning, memory, and learning. These cognitive processes are more necessary to humans compared to other species. A selective pressure which favours an increase in genetic expression and allele selection that count towards increased synaptic plasticity is an example of evolutionary neoteny once again. Neuronal neoteny shows an adaptation of specific human neurons that come from areas of association, memory, and social interactions. The retention of these thoughts into adulthood provide evidence for the concept of pedomorphic characteristics being retained. The concept of neoteny is also supported by experimental evidence, as well as having real-life evolutionary applications. In Belyaev and Trutt's silver fox experiment, they developed a scale for tameness and selected the tamest wild silver foxes with the main purpose of testing the process of domestication in real life. He believed that the critical factor in the anatomical and physiological changes seen in domesticated animals could have also been the result of tameness. He also hypothesized that the process of domestication was the result of changes in gene expression. Silver foxes' behaviour evolved in the following ways over the course of 6 generations. They began to lick the experimenter's hand, allow humans to pick them up and stroke them, and wag their tails when they got close. The morphological characteristics of the tamed foxes evolved, with some having curled tails and floppy ears. Levels of serotonin also increased, producing happier foxes. Later experimenters found that facial features of the foxes became more juvenilized, rounder and shorter snouts and chunkier bodies. This shows how the silver fox experiment provides evidence for neoteny being an evolutionary concept. Overall, neoteny can be viewed as an evolutionary concept, as Lorenz believed that juvenile traits can preserve survival as more adults pay attention to individuals with these traits, which can be seen in humans, animals, and even portrayed in cartoons as shown previously in this video.
Created using Powtoon.